So now I want to look at some of the problems that we had that I asked you to graph. And we had several different ones. We had y is equal to x plus 11. We had that y was equal to the absolute value of x. We actually had x is equal to the absolute value of y minus 3. And then we had y is equal to the absolute value of x minus 2. Now, looking at all four of these, we need to talk about a couple of different things. With these, none of these are going to be straight lines. One thing that we have to recall is a straight line is going to look like a y equals mx plus b. In other words, we're going to have a y and an x. We may have some numbers in there, but there's not going to be any of this notation, any of these symbols in there. So many of you did go ahead and get an XY table, but you didn't have the full shape of the graph. Or you put arrows on both ends, or maybe you just plotted the points, because some of you had this, you plotted the points, and then you just stopped. Well, just because those are your points doesn't mean that the graph actually stops there either. So with these equations, we need to know their basic shape. And so the basic shape of a square root, y is equal to the square root of x, it's going to look like this. It's going to start out at a point, and it's going to go to the right, and it's going to continue to the right forever. Now that's with nothing added or subtracted. Y equals the absolute value of x. It's going to be some type of V. So both of these would have a V shape. The one that some of us needed to be careful about was this one right here. We actually have the absolute value of y. Whenever there's an operation or a symbol on the y, that usually means we're turning to the side. So this one is actually pointed to the side. With all of these, we have to look at where their starting point is. This point, here, here, also known as their vertex. Okay, all of these are basically known as their vertex. They're changing points. And the way that we can do that is we always look inside the operation, the symbols, the notation, that type of thing. And what we're going to do is we're going to set whatever's inside there equal to 0, or like in the case of the radical, we're actually going to set that x plus 11 greater than or equal to 0. The reason I'm setting it greater than or equal to 0 is because I can't take the square root of a -1 to be able to graph it. Yes, I can take the square root of a -1. If anyone recalls, that's that complex number I. It's an imaginary number. It's not a real number. It's an undefined number. It's something that we cannot graph. Okay? So it's not that real number. So on a graph, anything underneath the radical has to be greater than or equal to 0. And I solve it, so I subtract 11. So x is going to be greater than or equal to a -11. So whenever I do my xy table, what I can do is I can start at -11 and I can go forward. Okay? If I'm looking at the radical, Usually I try to get some even numbers, but I don't have to because I can go -9, -8, -7, and -6. I'll just end up with decimals. But if you think about -11 plus 11, well, that's going to be 0. Square root of 0 is 0. -10 plus 11 is 1. Square root of 1 is 1. This is going to come out to be the square root of 2. Square root of 3. This will actually become the square root of 4, which is 2. And this will be the square root of 5. So if I go to graph this one, I'll actually start it at -11. Which is here. And so is here. Okay. And then I have this. And then I'm kind of doing this. And so this is what that graph would look like if I had y is equal to the square root of x plus 11. Now with your others, you would do the same type of thing. This one, x equals 0 is our starting point. So I need to find things on both sides. So I need to find -3, -2, or I could just start at -2, 1, 0, such as this. Well, the absolute value of 3 is 3. This is 2, 1, 0, 1, 2, and 3. So this is going to help me form my V. If you always start at 0 and just go positively, you're not going to get the full shape. You're only going to get part of it. So if I were to just start this one at 0, well, I'd get this. And I would only get this part of the shape. Whereas, technically, I should also be getting this part. So I should be getting this V. This is that y is equal to the absolute value of x. So we need to be able to recognize a little bit the shapes. Same thing with this one. If I set this x minus 2 equal to 0, if I add 2, x is equal to 2, that's actually going to be my middle point. So I'd have 2 in the middle, and then I'd go 1, 0, I'd go 3, 4, and then I could pick a -1. Okay. This is going to be 0. This will be 1, 2, and 3. 1 and 2. And so what this one is actually doing, let's go with red. It would start here, and it's going to move over this direction. But it's still going to be a V. Like this. So we've moved over 2 places, but it still has that V shape because of these absolute value signs. This last one is the one that we have more difficulty with. Anytime you have x equals, select values for your y. In other words, plug in -2, -1, 0, 1, and 2. Plug in values for your y. Don't try plugging in values for your x. Plug in values for your y. So -2, absolute value is 2. 2 minus 3 is -1. Absolute value of -1 is 1. 1 minus 3 is -2. 0, absolute value of 0 is 0. Minus 3 is a -3. Absolute value of 1 is 1. Minus 3 is a -2. And then that's going to give me a -1. So now I have -1, -2, -2, and so forth. And so if I come over here to graph this one, what this one will actually look like is I'm going to come over to this point, and it is going to go this direction. Let me come down to another graph. Might help us out a little bit. I come over to negative 3, 0. And I'm graphing, if I can draw straight lines, which I cannot. I try. But it's going to look like this. So this is going to be x equals the absolute value of y minus 3. So again, we have to be careful and make sure that we know the shapes of these. Make sure that you have that basic shape as you're going. Okay? Don't just draw one half of it. And definitely, one thing that I saw in some of yours was maybe you drew this part and then you just drew an arrow, or maybe you just left it. Well, the graph doesn't stop here. We've got to know what else happens, okay? So we have to know what's going to happen after this point. Does it continue down this way, or does it go back the other direction? So you need to make sure that you finish out the graphing. If you have questions, please contact me. So not waiting till the last minute to do the assignment, and let me know when you have questions.